Today we are going to talk about cointegration, and we are going to use the Johansen cointegration and then Engle-Granger cointegration. It is not going to be a long video, so without wasting more time, we can proceed with the Johansen cointegration. But before we proceed, we have to load our data into Gretl. As I've already opened Gretl, I will look for a data and then load it into Gretl. Well, I need to look for a data from my data set here. Okay, let's try this one. So you can just drop it and then it will give you the instruction to follow. First of all, I will just click on OK. Once I click on OK, it will ask you the form of data you're importing. So I'll go ahead and then click on yes. And I will go to time series, click on forward, annual. You have to put the range. I believe I selected from 1990. The reason why it is asking me these questions are I did not add the time or the trend in my data set. I should have put in a column indicating that it is a time series data. So without putting this year range, you have to do it manually once you're importing the data. Here, I'll click on forward, and it is done, saying the 1990 to 2019. So I'll click on apply. Then when I come here, I'll just close this one because I don't need the data set again. So once you're done with this one, as we did in the previous video, we have already conducted the unit root test. And once they pass the unit root test, we need to follow up with the co-integration. Here I'm using different set of data sets because I just want it to be a little bit simple for you to understand. You can use any number of variables you want, but the more you add a lot of variables, the more you lessen the degree of freedom for the lag selection and everything. First of all, before we go into the co-integration, you need to go to model, then you go to multivariate time series. First, select lag var lag selection. Here, we will put all the variables. I will select all of them and then move them here. In order for us to continue, we need to select the maximum lag. You can select any lag you want once you have a degree of freedom among the variables. So you have to continue. For me, I'm going to select up to maybe lag 4. Okay, lag 4. Once I select up to lag 4, leave it this way, include the constant. Click on OK. I have clicked on OK. As you can see here, it shows that it's giving you the information about the output you have here and the criterions it used. You have the BIC, you have the Hannan-Quinn, you have the AIC. And here we are comparing the p-values. And the best way for you to determine the optimum lag is look at the asterisk attaching to each of the information criterions. You can see Hannan-Quinn, Bayesian criterion, Akaki information criterion. And when you check from this point, you can see that the Akaki is pointing to lag 4, which is the asterisk attached to this one. And here, BIC is also pointing to lag 4. Hannan-Quinn is pointing to lag 4. So we can conclude that our maximum lag that we can use here is lag 4. Let's try. Some people will be willing to use maybe less of these lags, or might select from lag 1 to maybe lag 3 or lag 4, lag 5. For me, I'm sticking to lag 4. Let's just try it this way. You can try it whilst you're at home. So the next step is I'll close this. I know that I have the maximum lag I'm going to use. So I'll close this. Once I close this one, I'll go back to model, go to multivariate time series. Then I'll go to Johansen cointegration. You can see the variables are at level, so it's asking me the lag order. I'll select up to lag 4, and then I'll allow this one to be this way, showing that you have unrestricted constant, and then click on OK. If you click on OK, you'll get an output this way, which is giving you a lot of information. But what we need here is from here to here. It's from here to here. So once we have this output, I have opened a Word format here. So I'll try to move this one to this side a bit so that we can open our Word document here. And I'll bring this one to this side. So I have my Word here. I'll move it a bit. So you can see that based on this output, I've already created a table for this one. Let's say I have already created a table and then independent variables. So once I put GDP first, it means that I'm making GDP as the dependent variable. So for this point, what I need to do is that I am using two variables. I created a lot of, rows and columns for this, and I will delete some of them because we have up to rank 2. So I'm going to delete this part from this table. Okay. We can add more whilst maybe they are more than this. So first, you have to understand the null hypothesis and then also understand the alternative hypothesis. At the null hypothesis, it says that no cointegration. The null hypothesis must be rejected at a 5% significance level, and the alternative hypothesis shows that there is cointegration. And mind you, if all the p-values here from the output are greater than 5%, it means that there is no cointegration. There is no long-run relationship between the variables. And looking at our output, we can see that we have the ranks, which I've also created here. We have the eigenvalues. I've also created created a column for them at this place. The trace test, I've created a column for it. I have created a p-value for it. And you have to understand that under the Johansen test, we have two different tests being conducted at this point. We have the trace test, and then we have the likelihood maximum test. I don't know about other statistical software you are using, but in Gretl, this is how it works. So what we are going to do now is that we have these variables that we imported, and then we have tested for the cointegration. So we can see from this point that the output is giving us whatever table we have created here. So what all you need to do is that you can just copy them and paste them. So let me start with here. So I'll number this point 0, 1, and then 2. So at this point, I will just have to copy these variables, or now these numbers, and paste them here. I'll paste them here. I just need some point of it and paste them. So I'm going to paste them here. I'll paste them. This side is for the trace test. So I'll be pasting all of them. Then we need the value for trace test. So we just have to paste them here. And we are copying all of them. We are copying all of them. And we are going to paste all of them here. Copying all of them. So you can see the p-value for rank 0 0.0. So you can see we need 3 figures after the point. So we paste. I'll delete the 1. I have already deleted it. I'll copy up to this point and paste this one too. I'll copy this side to this side. Okay, let's make it this way. And also copy this side. And also go here and copy this one. So I'll copy the p-values. And then also copy this one. Also go here, copy this one and paste them here. I'll delete them, some of them, and leave the numbers up to 3. And here the conclusion is that rejected. Here too is going to be rejected, and here not rejected. Basically, here what you see here is that, okay, let me just try and explain something here first before we come to the table. Looking at the output here, some of us can just look at this place. The renormalized beta shows that here, whatever value you find here, the value or the sign attached to it, you need to multiply it by -1. That is the rule. So looking at this point, if you want to get the coefficient from the cointegration, you multiply the 14 by -1, which will give you +14. And if you multiply this one by -1, it will give you -0 point this. So it's giving you that in the long run, FDI has a positive impact, and then export has a negative impact. These are the coefficients, so you can get them from the renormalized beta from this point. You just need for this variable because these are the independent variable. Without wasting much time, I'll close this one as well, and then we go to the main results that we have, which we have already inputted here. So from this point, you can see that at rank 0, we rejected the p-value for the traced test because the p-value is less than 5%. It's always even also less than 1%. It shows that there is no cointegration. So we are rejecting the null hypothesis, and then we go for the alternative hypothesis, which shows that there is cointegration. At this point here, we are also rejecting the null hypothesis for the likelihood maximum test, showing that there is cointegration, because once you reject the null hypothesis, you go with the alternative hypothesis. Same goes with this part. This also shows that it is significant. You can see here at 5%, and it at 5%, because if you multiply this one by this, you get somewhere 2.6%, which shows that there is cointegration using the trace test. Maximum likelihood maximum test also shows that there is cointegration. And at this point too, at rank 2, you can find out that here, at this point, we are not rejecting the null hypothesis, and we cannot stick with the alternative hypothesis, as you can see here. But overall, there is cointegration, because when we count the number of p-values which we rejected, they are more than the ones we did not reject. So the majority carries the vote here. Therefore, we can conclude that there is co-integration between GDP, FDI, and exports with respect to the country or the region that we selected the variables for. So we can move. I think that is all for the co-integration using the Johansen. That is the quickest way you can interpret your co-integration test. Engle-Granger is a different co-integration test altogether. For instance, I already have a table here that is having some information already. So I will delete them and then we stick with the variables we are using. I just wanted to give you a sample of it. I will delete most of the things. So first of all, let me just delete this one. And also we are going to delete this one as well. And we will delete this one. So we will go back to Gretl again. Then we click on model. We go here again. You can find Engle-Granger here, cointegration. So you click on this one. So we are using lag 4 and we can use test down from maximum lag order, show regression results, and then we are using the option. There are so many options here. You can use with constant and trend, without constant, but let's stick with constant here only, because in the model maybe you might run, you will not include the trend. So stick with the constant and let's click on OK. You can also change this one, use the BIC, but for me, I am sticking with the Akaki information criterion, which is the AIC. After this, click on OK. I've already clicked on OK. Let's go here and check something. The Engle-Granger cointegration states that there is evidence of a cointegration relationship if. So there are two options here. We need to fulfill all these options. The unit root hypothesis is not rejected for the variables. That is the first option. And the unit root hypothesis is rejected for the residuals, which is the U hat, from the cointegration regression. So let's go to this output. Taking the variable as we performed the last time in the using the ADF unit root test, you can see here that here, don't get confused. This part is the unit root test for all the variables. For instance, when we use GDP, you can see here test with constant shows that there is a unit root present here. You can see here from this slide, you can see. And then here too is saying that you can see the same thing here. It shows that there is unit root at this point. Check from this place. You can see here there is unit root, as you can see in FDI. And when we go down, you can see that there is unit root also in export. So here we have not rejected the null hypothesis for all the variables we are using here, and it shows that there is unit root presence in the variables that we are using. So we need to go to the second option. The first option has been fulfilled, which is the A. It shows that there is a unit root presence in the variables because all the p-values are greater than 5%, as we studied in our previous video. So now we need to fulfill the second part, which shows that there is co-integration or not. So here, this is the B part, as you can see here, and then the condition is already here, as I've already inputted here. So you can check here, we are testing unit root test in the U hat. U hat is also like residuals. So let's check from this point. You can see here the model equation, or the model that we use here. You can see here I've already inputted them here, as you can see. That is what I've put in the table in the table here. So let's check from this point. Maybe someone might say that I should copy them. Okay, I can copy this one. So just copy this one. This is the model. This is your model. You can copy and then paste it here. You can copy your model, paste it. So this is the model. I've copied the model here, and then Let me just try to correct everything and make it look good. So you can see the unit root null hypothesis. You can see the estimated value of the alpha. This is the value, alpha minus 1. We copy this one. I can paste it here, but I need only 3 after the point. Here too, we need the test statistics. So I'll copy this one. Maybe let me copy from this point to this point and here, from here to here. So I'll paste it. I'll paste it here. And also look at here. This is the p-value we had. So I'll copy this p-value. Copy and paste it here. So what does it say? The second option is that now I can close this one because I don't need any information from this point. As you can see here, we're just going to stick to this point. So, or let me use this part to also, the output to also interpret something for you before we come to the word. So if we check from this point, you can see that this is the p-value we had from the unit root testing in the residuals or the u-hats. You can see that the p-value is less than 5%. And that means that we are rejecting the null hypothesis for the residuals. And it means that we've met the second option too. So this shows that there is co-integration between the variable we selected. And at this point, I believe everything is clear. So using the variables GDP, export, and FDI, we found co-integration through the Johansen test and the Engle-Granger co-integration test as well. Based on this, we can conclude that there is a long-term relationship between FDI, exports, and then GDP. So I believe this is clear and you have understood what we've learned about co-integration today.